So what we're going to do here is cover some different special factoring patterns for polynomials, and also another little factoring technique. Depending how a polynomial looks, you kind of build up the intuition of, an appropriate way to maybe try to factor. So the sum and difference of cubes, okay? In this section here, we're going to go over the sum and difference cubes. So the sum of cubes. So if we have two things that are added and each one of those things is a perfect cube, so in other words, something cubed, that this will factor into a plus b times a squared minus a b plus b squared. Okay, so that's a sum of cubes. So in order to do this, you're going to want to identify what am I cubing here, what am I cubing here. Notice, respectively, whatever's cubed right here goes in those places. Whatever is cubed here goes in place of the b. Okay, so a couple examples here. All right, so for example, let's go with we'll start with a cubed plus 27. So let's say we're factoring a cubed plus 27. Now, what you want to identify, and sometimes what you might want to do is go, all right, well, what's the value of a? What's the value of b? So in other words, I'm trying to think, if I rewrote this like this first, right? What do I cube to get a cubed? Well, clearly that should be a. And then what do I cube to get 27? 3. So that tells me in place of the a up here, what am I going to replace? Well, is in this example a. And then what am I going to replace the b with? Well, here's b right here. Here is my b, the value for b cubed. So b is going to be 3. So that means that in the factoring, right, I kind of have this little template, a binomial. Here's my binomial. Here's then my trinomial. And I replace respectively a and b with a and 3. So it's going to be a plus 3, and then a squared minus a times b, or in this case, a times 3. So 3a, and then plus b squared, in this case, 3. So 3 squared is 9. Okay. So what is a cubed plus 27 factor into? A cubed plus 27 factors into right there. Okay. Let's do another one of those. Okay, in this case, let's go with x cubed plus 125. We'll start with that one. So like we did before, one of the things you might want to do is you just kind of set some parentheses and identify what would I have to put into this parenthesis to cube to get x cubed. Well, pretty clear it should be x. And then what do I have to put into this parenthesis to cube to get 125? Well, 5. So that tells me in that sum of cubes formula that what I'm going to replace the a with is x, and what I'm going to replace the b with is 5. So now what does this factor into? This is going to factor into this binomial times this trinomial. We're going to have a plus b, or x plus 5, a squared. In this case, the value for a that I'm replacing is x, so x squared, minus a times b, or 5 times x, and then plus, lastly, b squared, or 25. Okay, so there is the polynomial x cubed plus 125 factored. It is a sum of cubes. Okay. Now, there's also a difference of cubes, and the only real difference there, okay, the only real difference is the sign. So if I have a cubed minus b cubed, that this factors into a minus b times a squared, now plus ab, and then lastly plus b squared. Okay, so notice how the signs change. When it was a cubed plus b cubed, it's a plus b, a squared minus ab plus b squared. So we got a little flip-flop of these signs here. So for example here, All right, so a little example here. Let's go with about this time we do let's start with a kind of pretty basic one. So let's go with y cubed, and we'll go with minus 64. Okay, y cubed minus 64. And when you look at this and you say, well, is there a monomial? No, there's no monomial. And it's how it looks. This looks like a difference of cubes. You got to kind of have these in the back of your head somewhere. Difference of squares, quadratics that look like they could be factorable using maybe the MF Doctor stuff. So when I look at this, I think, all right, well, what do I cube? What do I cube to get these respective terms? Y cubed. Well, y. 64. What do I cube to get 64? 4. 4 times 4 times 4, 64. That then tells me what I'm going to replace with in these respective spots for the A and B's, right? This is the value of A. This is the value of B up in that little formula up top. So up here, now I know this is going to be, again, a binomial times a trinomial. And what do we have here? Well, it's going to be y minus 4, y squared, plus 4y, plus then 4 squared, 16. All right, so there is that difference of cubes factored. Okay, and then over here, let's go with this one. Make this one. This one's gonna be a little different. We're gonna have 27. Okay, let's go with 27b cubed minus x cubed. So it's 27b cubed minus x cubed. Now notice here we have what? We have a difference. I see cubes, right? So I'm thinking maybe it's difference of cubes. And what you want to do is identify and say, what can I replace with those parentheses to get this term? So what do I plug in here? Is there anything I could plug into that parenthesis so that when I cube it, I get 27b cubed? Okay. And I think you would come up with, well, 3b. So if I take 3b times 3b times 3b, I get 27b cubed. What do I replace in this parenthesis to cube to get x cubed? X. Okay. Now I put the letter b in front so we understand that this here, though, is up in this form. This is the a, right? That's my a cubed minus b cubed. Okay. Now be careful here. So now when we factor this from here, what are we going to have? We're going to have a binomial times a trinomial. Okay. And we're going to have what? A, well, in this case, a is 3b minus b, which is x. Now here, be careful. Now I'm going to say this. Don't write this down just yet. Watch. I now have to square what? I have to square this thing. In this case, I have to square 3b. Don't just write this. Don't write. This is not 3b being squared. That is just b getting squared, then times 3. Okay, so what we got to do is we got to make sure that we're taking and squaring 3b. Okay, then plus, okay, 3b times x. Okay, so we might write that as just 3bx. And then plus here, x squared. And since we don't have that one term, that's fine. We can write just like that. Now notice, what does this become here, though? What's 3b times 3b? All right, well, that's going to become 3b minus x, and then kind of write it out as 9b squared plus 3bx plus x squared. Okay, now there's that one. Difference of squares. Okay, a little more complicated, a little more going on. Okay. That is the sum and difference of cubes. Okay, so you just kind of got to get familiar with identifying what are you cubing, if it's a sum or difference, and recognizing the difference really between these two is not much going on. So read that over, check it out, let me know.